Hello guys, let's begin our journey in building our Ant language. As you see here, we have the syntax of the Ant language. It's simple syntax. As you see, we have a print statement, a semicolon, var for declaring variables, if statements and else statements, and so on. So, our first step in building an interpreter is the reading the file, and after reading the file we need to store the contents of the file in some array. It's like this. So as you see here, we have a bunch of characters from this file. As you see, print, some space, the string begin and some space, also semicolon, and some return chariot or just a white space, and so on until we find an end of file. Then we will build our first model called tokenizer. This tokenizer is just a simple software that map each token with its proper type. As you see here, the result of tokenization, we see a bunch of tokens from this file. Print is a token print, begin program is a token string, semicolon is a semicolon, and so on until we find a end of file, and we map it with a type of token end of file. So let's jump to our shell. In the project directory, we will make the directory for that project. We will name it Ant language. Then we will change the directory to Ant language. So as you see, it's empty. So let's start by building our first entry point, just to read the file and print the content of the file. First, our Ant interpreter, it will be executed in two modes. The first mode is a script mode, and the second mode is the interactive mode. In the script mode, we will take as an input a file, and then we will process that. In the interactive mode, we just print, we just go in an infinite loop, and we are waiting for the user command, and we run it at runtime. So let's make our first entry point. This language, it will be hosted on C language. So let's begin. We will include std.io model, and then we will need also stdlib, and let's start our entry point. We need to read arguments from, we need to get argument from user. So if the count of argument is 2, then we are in the script mode, and then we will run the file that user give us, and we will give as an argument the second argument, it's the file name. Here pass the file name. Else if the argument count is 1, then it should be the interactive mode. We will run a helpful function. It just simply means read, evaluate, print, loop. else we will print an error. Printf in the standard error too much arguments. Okay, then so excuse me, it's fprintf, then we will print to the user the usage. Our interpreter is called int, and we expect a file. It's optional, and we abort, we exit. If all is okay, we will return 0. Okay, so now let's create our run file and REPL function. So let's do a prototype here. Okay, and let's define this function after the main function. Okay, and also REPL. So let's start with the easiest one, is the REPL function. We will declare a list of characters. Let's make a maximum character 200, and we will make an infinite loop, and then we'll printf some symbol to say that we are waiting for some command from it. So we will use in this a function called ifgets. We will pass it our buffer, then we will, in the second parameter, we will give it the size of our buffer. Then we will read from the standard input. If that is null, then something is wrong. We will printf enable to read 9, and then we will exit that. So to test that, we need to printf what we read in the line. We will say I have let's say we have read this. Okay. So let's save that, and we run our command gcc to build our project, gcc main.c. So as you see, we have the executable, then we will run that in the interactive mode. So let's make var x equal to, so as you see, we have read var x, print hello world. Okay, let's exit that, and let's come back to our main. So now we did something better. Let's move on to the script mode. When we will pass a file name, then we will read that. So first thing first, we will read the file, open the file in the read mode, file, file, if open, file name, and we will pass the read mode. So if file equal no, then we will print the error that occurred. So we just print error. This function will handle what is the case of that error, and then it will print the statement of that error. If something wrong, we will just exit. Okay, now we need to declare an array that we will store every character from that file. The challenge thing is, what is that count? We need to know. We need to know how many characters to reserve. So to get that, we will use a function called fseek. So let's do some man for fseek. As you see here, it's on the library stdio, and it accepts as a parameters stream and the offset and heads. So let's see. Okay, we will use that one. The hence, if we put seek set, it will get to the first of our file. If we do a seek end, then we are at the end of the file. It's just a helper function that move the cursor down to some position in the file when we give it some offset. So that will be helpful. Let's go back and use that function, fseek file. We have no offset from the position of the cursor. So I will do set the position of cursor at the end of the file. So after that, we will use a function called ftell, and we'll pass the file as argument. So let's see what's that function. Okay, ftell function update the current value of the file indicator from the stream pointer to by stream. So the return value, okay. So let's read that. So as you see, fseek function set the file position and the new position measured in byte is obtained by adding offset byte. Okay, we have three parameters, set, secure, and seek end. The offset is relative to the start of the file. Okay, a successful okay. Ftell, we will return the ftell function. It will return the number of bytes at which the cursor in. So let's back to that. So this, we will return the number of bytes in the file. So after that, we will use also fseek to return back the cursor at the start of the file. So we have now allocated our source with the exact number of characters in our file. So let's read our file now and then put every characters in this array source. To do that, we will set a read count variable for the function ifRead, and we will pass it our buffer. Then we will do some size of that, and also we need the size of the file, the size of the source array. Okay, that's the size of source, we pass the file pointer. So if read count is different to the count, we will simply print the error. That means the if read can't read all the characters. Error enable to read the file, and we specify that file. Finally, and we simply exit by 1. So at the end of the array, we will put the characters, the null characters, and we will close the file point. So we need to test that. We simply printf we read okay, and we pass that source. So let's test. Let's do our command to build our file. Oh, everything is going okay now, and let's make a file sample.ent, and let's print again for x equal to if true empty body. This is just a comment. So print, and if all is okay, then we will get the whole content displayed in the command line. So let's do and will pass the file called sample. So as you see, it tells we read this. Okay, we are on the right track. So let's pass some file that not exists. Let me show you our current directory. So I will pass some random file that does not exist. So as you see, it prints no such file with the action. Okay. Now we did something fun. So after I read this, I need something that interpret this file and get the result. It reads all the source array, and then it executes our program. Also here, it reads the line and it will execute it. So to do that, Simply now we will comment interpret source. It's a function that we will build in the next session. It's a helpful function. We will not build it right now, but we will comment that and we will return back to it to implement it. Also here we need something to interpret that line that we've read. Okay, now we've made our first entry point that execute the end language on two modes, interactive mode and script mode. Okay, so now let's build our scanner. Let's build our scanner. Remember that the objective of this session is to build that model that tokenizes this source. So we have source code. So now we have the entry point that returns to us this stream of characters. Now we will build another model that handles this source code, and then it will return our tokens. It maps each one with its appropriate type. So let's do that. Let's jump to the code. Now we will create a header file for all type of tokens. So let's make that fem. Let's create a scanner.h. We will do some guard and scanner. If the macros is not defined, we will be defined just to avoid the circular import, the issue of circular import. It's called card. Then we add that and f. So let's create our enum of token types. This enum type def enum. Let's have the name token type, and simply we will write all the tokens that we need. The tokens that we need, it's token plus, we will use that for arithmetic operation, token minus, token star, token slash, token equal, token equal, then token not equal, okay, token less equal. So you get the idea. I enumerate all the tokens type that I need to build the scanner. Token greater equal, token left parent, token right parent, okay, token left brace, token right brace, also token semicolon, token comma, and token dot. token identifier and token string, token number, and we have the keywords of our language. It's reserved keywords: token var, token print, token if, token else, token while, token for, token function, and token class. This language, it will support the paradigm of object-oriented programming, so we need a token called class. Okay, also token this, token super, token nil, token return, token true, token false, and token or. And finally we have token error in the case that we don't recognize some character, and token end of file. Okay, so now let's create a useful function, a useful structure type. The first structure type called type def struct. It's called token. We will track the token type, then its starting character, its length, and the line in which token is defined. Also, we will have the major module called scanner. This scanner, it will track current character, and it will need to know where is the start of the token, and also it will track the lines. Finally, we will make some initializer that initialize our scanner, and we will pass the source code, and then we have a function called scan token. When we call that function, it will return some token. Every time I will call this function, it will simply return a token. For the first call, I will say scan token. It will return first token. If we also invoke that a second time, we will return the second token, and so on. You get the idea. So let's make the implementation of these two functions in the scanner.c, the file of the implementation.